one of our goals in thinking through things you can see in the sky without the aid of the telescope is to understand the phases of the moon. The moon is one of the most prominent things that's going to change in our sky from day to day as it's zooming around in its orbit around the Earth. So we want to understand phases of the moon. And there's a lot of common misconceptions about phases of the moon, and hopefully through this tutorial we'll be able to catch those misconceptions if they happen to be ones that you hold. Alright, so we have figure 1. Figure 1 shows the Earth and the Sun and 5 different possible positions for the moon during one full orbit. So there's the orbit of moon around the Earth, counterclockwise as viewed from above. It's important to recall that one half of the moon's surface is illuminated by sunlight at all times. So you see, no matter which one of the lettered positions we're looking at, half of the moon is facing towards the sun and it is in sunlight, half is facing away, and that's darkness. For each of the 5 positions of the moon shown below, the moon has been shaded on one side to indicate half of the moon's surface that is not being illuminated by sunlight. Note that the drawing is not to scale, because if that's the Earth, that's not the moon. They're not the right distance, and it's not the right distance between the Earth and the sun. It's just so it can fit in a picture, not to scale. Alright, question 1. Which of the moon positions, A through E, best correspond with the moon phase shown in the upper right corner of figure 1? So which position of the moon matches that moon phase? Make sure that the moon's position you choose correctly predicts a moon phase in which only a small crescent of light on the left-hand side of the moon is visible from Earth. So it has to be a crescent on the left-hand side. Alright, so let's go through and see what we see in each of these. So let's put this down to sort of indicate what part is visible to Earth. In this view, it's lit up on the right and it's dark on the left. Go tangent to the circle again. Now from the Earth's point of view, when I'm facing the moon, it's going to be lit up on the left and a little bit of light is missing on the right. If I'm standing on Earth and facing the moon, it's going to be lit up on the left, dark on the right. So far none of these are matching because none of them are even a crescent. D and E are both crescents, so now we need to a little slower and think a little bit more carefully. So now I've got that tangent to the circle to show you what part of the moon we can see from Earth, and I see that as I'm facing the moon, it's going to be all dark on the right and a little crescent of light on the left. And bingo, that is just what we needed to explain. A moon phase in which only a small crescent of light on the left-hand side of the moon is visible from Earth. And so you can see how that's different. I put this tangent to the circle. This is also a crescent moon, but for this crescent moon, it's going to be dark on the left and illuminated a crescent of light on the right. All right, so letter for our choice is be D. In the blank boxes below, sketch how the moon would appear from Earth for the 4 moon positions that you did not choose in question 1. Be sure to label each sketch with a corresponding letter indicating the moon's position from figure 1. So just sort of go around the horn here. E. So in E, I'm going to have a crescent of light on the right, and it's all going to be dark on the left. Something like that. And A, so for A, it's almost all illuminated. It's a gibbous. And it is all illuminated on the right, and there's a little crescent of darkness on the left. Like that. In B, it's also a gibbous moon, but now we're on the waning part of the cycle. And it is going to be illuminated on Earth facing the moon. Left side is lit up, and there's a sliver or crescent of dark on the right side. Yeah, I didn't label that. Bad me. So this one is B. So I need to have everything illuminated on the left and a little crescent of darkness on the right. And the last one is going to be for D. Oh, sorry, C. I already did D. So for C, this is our third quarter moon, our half moon. And as I'm on Earth facing the moon so I can see it, it is going to be the left-hand side lit up, the right-hand side dark. So the left-hand side lit up, right-hand side in darkness. All right, let's move on to the next part. Shade in each of the four moons shown in figure 2 to indicate which portion of the moon's surface will not be illuminated by sunlight. I'm afraid my pen might be too fat for this, but we'll try. Derp, derp. Yep. That. Derp. Derp. Okay. A little bit of overkill. Overzealous with my fat pen. We're going to use figure 2 to answer questions 4 through 7. Which moon position F through I best corresponds with the moon phase shown in the upper right hand corner of figure 2? So that is a new moon. I can't see the illuminated side of the moon at all because it's facing away from Earth, and that is F. Question 5. How much of the entire moon's surface is illuminated by sun during this phase? None, less than half, half, more than half, all. Well, the half of the moon that is facing towards the sun is in sunlight, and the half that is facing away is not in sunlight. How much of the moon's illuminated surface is visible from Earth for this phase of the moon? Well, all of the illuminated side is facing away from Earth, so I can see none of that surface. So none of the surface visible from Earth is illuminated. Still half of it is in sunlight, but none of it is facing me. Hence, that is a new moon. All right. Would my answers to questions 5 or 6 change if the moon were in third quarter phase rather than the phase shown? Let's go back. Would my answer to question 5 if I was over here at I in third quarter phase? So how much of the moon's surface is illuminated by the sun during this phase? Well, still half. Okay, how about for answer question 6? How much of the moon's illuminated surface is visible from Earth for this phase of the moon? So in third quarter, how much of the illuminated surface is visible? Well, half of it is. Hence why it's called a half moon. C. Half of surface visible from Earth. illuminated. So the answer to 5 does not change. The answer to 6 does change. Alright, we had a little discussion between our old friends, student 1 and 2. Consider the following discussion between two students about the causes of the phases of the moon. Student 1. The phase of the moon depends on how the moon, sun, and earth are aligned with one another. During some alignments, only a small portion of the moon's surface will receive light from the sun, in which case we would see a crescent moon. Student 2. I disagree. The moon would always get the same amount of sunlight. It's just that in some alignments, Earth casts a larger shadow on the moon. That's why the moon isn't always a full moon. So do you agree or disagree with either or both? Big disagree with both. Both our students are wrong this time. They are very, very lost. So, which out of what they said is incorrect? So let's look at student 1. The phase of the moon depends on how the moon, sun, and earth are aligned with one another. So far, so good. During some alignments, only a small portion of the moon's surface will receive light from the sun. That is incorrect. Half of the moon's surface is always facing towards the sun, so half of the moon's surface is always illuminated by sunlight. Phases of the moon is about how much of that half we can see here from Earth. Either all of it, full moon, none of it, new moon, through the various phases of crescent, half, and gibbous. All right, so how did student 2 do? So I disagree. So far, so good. The moon would always get the same amount of sunlight. Good. It's just that in some alignments, Earth casts a larger shadow on the moon. This is actually one of the most popular misconceptions. Phases of the moon has nothing to do with Earth's shadow. Earth's shadow is what causes a lunar eclipse. The moon shadow on Earth is what causes a solar eclipse. So, phases of the moon are not explicable by Earth's shadow. Earth's shadow does play a role in astronomy, but that role is for eclipses.